In the previous video, we learned about two new basic exponential functions, and now in this video, we want to use transformations to sketch the graph of more complicated exponential functions. So in the first example, we have f of x is equal to -2 raised to the x plus 3 power. The basic function is y equals 2 to the x. And then there are two transformations. There's a plus 3, which is inside the basic function, right? That's applied to the variable before the exponent is applied to the base. So plus 3 inside is going to make a shift left 3. Shift left 3. And then there's a minus sign out in front. That's applied after the exponent. So that's outside the basic function. And so that would be a vertical reflection. And to be clear, we're talking about reflecting over the x-axis. Okay, let's go ahead and draw the graph. Remember, the graph of y equals 2 to the x has a y-intercept at 1 and a horizontal asymptote at y equals 0. And when we go out to the right end of the graph gets very steep very fast. So there we go. And then if we want to shift to the left 3 units, then let's start by taking the y-intercept over to the left 3 units. So 1, 2, 3. And the point at 0, 1 now moves over to -3, 1. And then we can just draw the curve through that point, trying to match the shape of the previous curve. And then the last step will be to reflect over the x-axis. Again, we'll work from the point at -3, 1. And when we reflect it over the x-axis, it's going to wind up over here at -3, -1. And then we can draw the rest of the reflection through that point. Notice the horizontal asymptote never changed. It's still at y equals 0. And the only thing left to do would be to label our graphs f of x equals -2 to the x plus 3. And then we could go back and label the original graph y equals 2 to the x, and the intermediate step y equals 2 to the x plus 3. Okay, one question maybe I'll ask before we go on. Is it clear that f of x crosses the y-axis? It gets so steep so fast here that sometimes students look at this graph and maybe they think of the y-axis almost like a vertical asymptote now, and it's not, you know. The graph gets steep, but it keeps going out to the right forever. And so just for fun, just as an extra question or an aside, we could ask, what is the y-intercept of the new graph? Right? If we want to know, then all we need to do is just plug in 0 for x. So f of 0 would be -2 raised to the 0 plus 3. So that's 2 to the 3rd power is 8 with a negative sign in front. The y-intercept is at 0, -8. And you can see that that's way down the graph. Based on the scale here with the 1 and the -1, you'd have to go quite a way down the graph to get to -8. So that's why the graph looks so steep, the green graph and the red graph too. Okay, let's move on. Let's go to example 2. In example 2, we have a very similar function, but different. Notice our basic function is still going to be, our basic function is still y equals 2 to the x. Maybe I could just abbreviate that basic function bf, and then y equals 2 to the x. And then transformations, I'll abbreviate that. I'll just write trans, and then we're multiplying by -1, but in this example, we're doing it inside the basic function, right? In the first example, we did it outside. So in example 2, multiplication by -1 inside the basic function is going to be a horizontal reflection. So we're going to start with a horizontal reflection. Which is over the y-axis. And then we have a +3, which is outside the basic function this time. So that's going to be a vertical shift instead of horizontal. This is going to be a shift up 3. Shift up 3. So the transformations in the two examples are similar but different, and it's nice to compare the effect of having the transformation inside versus outside the basic function. Okay, well, let's go on and let's sketch this graph. Might be good if you pause the video and try to graph it for yourself. We can start with the x and y axis, and we can draw the basic function again. And we can label the horizontal asymptote at y equals 0 and the vertical intercept at 0, 1. And then we can even write y equals 2 to the x up there. Okay, and then we can go ahead and reflect this thing horizontally. So the piece on the right side is going to go to the left, and the piece on the left is going to go over to the right. Can you see what that's going to look like? Something like that. Something like that. The horizontal asymptote didn't change. The y-intercept didn't change either. And this graph is y equals 2 to the -x. And then we want to shift this graph up 3 units. And so how should we do that? Well, if you said let's shift the y-intercept up 3 units, that's a great answer. That's a good start. Let's go up 1, 2, 3. So the y-intercept was at 0, 1. Now it's at 0, 4. Now, what else needs to be shifted up 3 units? The whole curve needs to come up 3 units, needs to pass through this, this point at 0, 4. But before we do that, let's take the horizontal asymptote and shift it up 3. We learned to do that with a rational function in section 3.5, and so now we're doing it again. So let's go ahead and draw the new horizontal asymptote at what? At y equals 3. And then let's draw the curve through that y-intercept and approaching that horizontal asymptote. And there is a nice graph. That's g of x equal to 2 to the negative x plus 3. Okay, we finished the problem. There's one more thing that I want to say before we go on. And I want to ask you, does the graph of 2 to the negative x look familiar? This graph here in red might remind you of a graph we've seen before. Remember the graph, so the graph I'm thinking of is 1/2 raised to the x. And so that was one of our basic functions in the previous video. Let's just sketch that graph real quick. It'll be the same as the red graph. It'll be the same sketch as the red graph. So they look very similar. And the question is, why is that? Well, in fact, they're the same graph, and the reason is a property of exponents. Property of exponents says that 2 to the negative x is the same as taking the reciprocal of the base and changing the sign on the exponent. So 2 to the negative x is exactly the same as 1/2 to the x.